Hello everyone, and welcome to the Categorical Plots lecture for the seaborn section of this course. Now we're going to shift our focus to plotting categorical data. Let's go ahead and jump to the Jupyter Notebook to get started. Okay, here I am at the Jupyter Notebook, and I've already put in a couple lines of code here. I said import seaborn as SNS. I went ahead and said matplot inline so I can see the visualizations inside of the Jupyter Notebook. And then I went ahead and loaded the tips dataset, and then I checked out the head of the tips dataset. Okay, for categorical plots, we're mainly going to be concerned about seeing the distributions of a categorical column, such as this sex, gender, or smoker, day, time, in reference either to one of the numerical columns or another categorical column. Let's go ahead and start off with the most basic categorical plot, which is the bar plot. And you can do that by calling SNS bar plot. And a bar plot is just a general plot that allows you to aggregate the categorical data based off of some function, and by default that's the mean. You can almost think of this as a visualization of a group by action. Let me go ahead and show you what I mean by that. We're going to go ahead and set an x, y, and data argument into bar plot. I'll start with data because that's the easiest, tips. And then what I'm going to go ahead and do is set the x-axis to a categorical column. In this case, I'll go ahead and choose the sex column here. And then for the y column, for the y axis, we can choose a column that's numeric. For instance, total bill. And this will create a bar plot. And by default, what it's showing you here is the average or mean of the total bill per categorical column value. So the average total bill for males is going to be slightly higher than the average total bill for females. And you can go ahead and change what's known as the estimator object if you want to basically affect what the actual grouping or aggregation here is. And we can go ahead and do that by adding another argument here, estimator. And here, if we go ahead and do Shift Tab so we can actually see the Jupyter Notebook's documentation for this, the estimator is a function that is an aggregate function. So it's some sort of statistical function to estimate within each categorical bin. And by default, that's going to be average or mean. But I can also put in my own functions. If you have some sort of aggregate function, you can go ahead and put that in. Right now we're looking at the mean total bill, but let's say we wanted to figure out the standard deviation per gender. For instance, is there more standard deviation on males in their total bill, so more variance, or do females have more variance? What we're going to go ahead and do is say import numpy as np. Let me go ahead and copy and paste this and put it in a cell above this. I'm going to go ahead and insert a cell above. I'm going to say import numpy as np here. And then in the estimator, I'm going to go ahead and pass in the numpy std function for standard deviation. And this will tell me when I run this what the standard deviation of the total bill column is per category. And you can pass in whatever estimator function you want. You can even create your own. And you can pass it into bar plot, where x is a categorical column and y is some sort of numerical column. Then you pass in your data and whatever estimator. And this is just an aggregate, or essentially just a visualization of some sort of group by mechanism here. All right, let's go ahead and build off of this by doing a count plot. A count plot in seaborn is essentially the same as a bar plot, except the estimator is explicitly counting the number of occurrences. And because of that, we only set the x value. And then we set in the data equals tips. And this is essentially the same thing as saying like pandas.count off of this tips column for gender. All right, and that's the basics of the count plot. It's essentially the same as a bar plot, except the y-axis has already been chosen for you. It's going to just count the occurrences. And here we can see there's more males in the data set than females. Let's move on and talk about box plots and violin plots. These type of plots are used to show the distribution of categorical data. A box plot is also sometimes known as a box and whisker plot, and it shows the distribution of quantitative data in a way that hopefully facilitates comparisons between variables. Let me go ahead and show you what I mean by that. I'm going to create a box plot by saying sns.boxplot, and then we're going to pass in an x and y. In this case, I will choose x to be a categorical data point or column, and then y is going to be numerical. Let's go ahead and go total bill. So here we're going to try to see the distribution of total bill per day. And then lastly, I have to pass in data as tips. Let's go ahead and run this. And here we get our box plot out. Okay, this box plot shows the quartiles of the data set, while the whiskers extend to show the rest of the distribution. Except for these points that are outside of these whiskers, these are determined to be outliers. And you can essentially just interpret this as from, for instance, if we look at Thursday as a day by itself, we have on the y-axis total bill. And then on the x-axis is just separated by category or day. So if I look at this blue one right here all the way on the left for Thursday, it's essentially telling me that about 25% or a quarter, which is why these are called quartiles, of the data points go from this end of the whisker to this bottom here. And then another quarter go from the bottom of the box to the middle here, this line, and then etc. for the top. So about another quarter of the points are here, and then another quarter of the points are here. And these dots are outliers. And we can begin to get really fancy with seaborn by just adding a few more words of code here and specify a hue. And that's going to allow us to kind of split up these box plots even further by another categorical column. In this case, we'll go ahead and say hue equals smoker. And if I run this, now I see the box plots split per day and also split by smoker status. And smoker status is colored here for you. And here you can now compare not only day by day behavior for total bill, but also by whether or not this person is a smoker. And that's really the true power behind seaborn. It quickly allows you to add this hue indicator, which essentially gives you a whole nother layer of data very quickly and very smoothly. And so you can compare that basically people on Fridays tend to have a larger bill if they're not a smoker versus if they are a smoker. And then you can begin to actually see the variation for smokers or the distribution for smokers versus non-smokers. All right, let's go ahead and talk about violin plots now. I'm going to go ahead and remove this hue here so we can see our original box plot, and then I'm going to call a violin plot. And a violin plot plays a very similar role to a box plot. And you can do it just by calling sns.violinplot. And what it's going to do is it's also going to show the distribution of the data across some sort of category. So it's going to take the exact same arguments as a box plot. It's going to take an X for the category. Your Y is going to be some sort of numerical column. Let's go ahead and stick with total bill. And then we'll pass in our data to be tips. I'm going to go ahead and run this and see what these plots look like. And let me zoom out so we can actually compare these two. All right, so we have our box plot on top and our violin plot on the bottom. Now the violin plot, unlike the box plot, allows us to actually plot all the components that correspond to actual data points. And it's essentially showing the kernel density estimation of the underlying distribution. And this is essentially just showing, if we kind of split this in half, the distribution of the points on its side. And this allows you to reveal even more information about the data points themselves. The cost comes at the fact that it's a little harder to interpret or read versus a box plot. A box plot is very easy to just take a look at, and you can quickly tell where roughly the data compares on a category. And violin plots will just give you a lot more information as far as the distribution of all the points themselves, but it kind of comes at the cost that you have to spend a little more time looking at it and understanding it. But these two plots are definitely very related to each other. It's just that the violin plot shows a little more information. Sometimes this information can be hidden from you if you're just using a box plot. And a violin plot, just like the box plot, also has the option to do hue. So I could say hue by sex, and it'll show me violin plots next to each other. But what's interesting about the violin plot versus the box plot is, as another argument, instead of putting two violin plots next to each other, since the violin plot information is essentially doubled up, I could have one half be one hue and the other half be another. And you can do that by saying split equals true as an argument. And then it will kind of split the distributions, and here you have a lot more information. now you can directly compare the distributions based off another category and see how the categories themselves on the x-axis compare to each other. Granted, this comes again at the cost that you're going to have to spend more time looking at this visualization. So you really have to know your audience and know what's appropriate when you're using seaborn and these advanced visualizations. If you're dealing with some more technical data viz people who are data scientists themselves and have seen violin plots before, these sort of plots are a great choice. However, if you're dealing with more kind of CEO, executive types, management people, maybe just a simple box plot, which is more popular, may be the correct choice, unless you find something very interesting in the violin plot. All right, let's go ahead and talk about a few more advanced methods for visualizing this sort of categorical data. We'll start off with the strip plot, and the strip plot is actually probably the simplest, but we're going to build off of it. Let me go ahead and zoom in here. We're going to go ahead and say SNS strip plot, and the strip plot is going to draw a scatter plot where one variable is categorical. So I'm going to go ahead and say strip plot, and we're going to do the exact same thing as we did before. X is going to be categorical, Y is going to be numeric, total bill, and the data is going to be equal to tips. And this is just essentially just a scatter plot based off of the category. One issue with this strip plot is that you can't really tell how many points are stacked on top of each other. What you can do is add another argument called jitter. And what jitter will do, if we go ahead and say jitter is true here, is it's going to add a little bit of random noise to separate some of these stacked points. And now you can see the thicker and more points there are is a lot more clear versus just the normal strip plot. So in the normal strip plot, if you had a bunch of points stacked on top of each other, it was kind of hard to tell. But now with jitter, you can see the density a little better. And with the strip plot, just like a violin plot, you can begin adding some of those extra hue arguments. So again, we could say hue is equal to something like sex, run this, and now I have color-based hues. And we can also do a split on this, just like we could with a violin plot. And this will basically split up these colors based off of your hue arguments. Okay, now a plot like this, again, you got to be careful with it. It may be hard to interpret versus a simple box plot or even a violin plot. Some people like to actually combine the idea of a strip plot versus a violin plot and create something that's known as a swarm plot. And seaborn allows you to actually do this. A swarm plot, if we go ahead and start typing it, is very similar to strip plot, except the points are adjusted so that they don't overlap. And this actually gives a better representation of the distribution of values. And it's kind of like combining a scatter plot, strip plot, with a violin plot. Let me go ahead and show you what I mean by that, and it'll probably be a little more obvious when you see it. We're going to go ahead and pass in the exact same arguments. Day for X. We'll say Y is total bill. Whoops. Total underscore bill. And then we'll say data is tips. And here we can see the swarm plot. And hopefully it's kind of more obvious how the swarm plot is essentially a combination of a strip plot and a violin plot. It shows the same distribution, except it's actually showing all the points themselves. One drawback to using a swarm plot, even though they're pretty nifty and cool in the fact that they show a lot of information, sometimes they don't actually scale that well to very large numbers, both in terms of the ability to show all the points. These points just go way too wide since you don't want to stack anything on top of each other. And it also takes a lot of computation to begin to arrange them. So I would advise not to use swarm plots for very large data sets. And in fact, I would say just in general, probably stay away from just showing swarm plots, since most people probably haven't encountered them before. As a quick note, if you do really like the swarm plot, you can actually combine it with a violin plot to show both pieces of information stacked on top of each other. You can say, in this same cell, we'll go ahead and say sns.violin plot, and we'll copy and paste the exact same information here into our violin plot. And we'll go ahead and specify the color of the swarm plot to be black. And this is actually going to plot both right on top of each other. And here you can see every single point and the corresponding KDE, or kernel density estimation plot, on top of it. Now there's a lot of information here, so be careful with this. this is probably more useful not for presentation, but just for exploratory data analysis. Hopefully these kind of plots help you just immediately understand your data, but not so much on the side of explaining to an executive. Those kind of things are better done with either box plots or these sort of count plots or bar plots. These kind of plots, these more advanced violin plots, strip plots, swarm plots, are just more suited for a data scientist themselves and how to actually read in or explore your data information. Finally, I want to talk about factor plot. Factor plot is actually just the most general form of all these plots. And what it does is, if we go and do Shift Tab here, it takes in an X argument, a Y argument, can take hue and data, but then it also just takes in a kind argument. And the kind argument is essentially what's going to describe the factor plot itself. For instance, we can say factor plot. We'll say, let me go and copy and paste that. X equals day, Y equals total bill, data equals tips, and then we can go ahead and say kind is equal to, let's say you wanted a bar plot, you can just say bar, and it creates a bar plot based off those categories. So all the plots we've been looking at before, the most general method is to call sns.factorplot and then actually specify the kind. So for instance, if we wanted to recreate the violin plot, you can call kind violin, and this begins to recreate that violin plot. Personally, I prefer to actually call the plot itself specifically, so sns.violinplot, strip plot, box plot, etc., versus calling the more general factor plot method. But know that this is available for you in case you want to call it. All right, that's it for categorical plots. Hopefully you saw a lot of the power that's available to you, and use this power wisely, especially depending on who you're presenting to. For instance, like I mentioned before, these box plots, easy to read, a lot of management people understand them well. These more advanced plots, those are more for you to explore the data. Okay, I hope you enjoyed this lecture, and I hope you've enjoyed seeing how easy Seaborn makes these visualizations for you. Everything we've been doing is essentially just one line of code, which is pretty awesome. Okay, thanks, and I'll see you at the next lecture.